Welcome everyone to the Python programming sessions. In this session, we are going to discuss about data management in Python. As a first step, what we are going to do is we are going to load the data frames that we created in our earlier session, import and export. In our import export session, we had imported a comma separated value file. We had imported fixed width format and we had imported Excel. And then we had saved those as Python objects in our hard disk. So now in this session, we are going to load those objects. To load a Python object, we require a pickle library. To save also, we had used the pickle. To load also, we will require the pickle library. So first two lines of the syntax is importing the packages which are required. Then we are going to set the working directory, changing that directory path. Now in my system, the objects which we had created was stored in dk2 analytics data file, and in data file there is a folder temp out, and in that the name of that object was given at that time was lr_df_1.obj. This dot represents the current working directory, which because of this syntax will become dk2 analytics data file. Mode is equal to read binary. At time of saving, we said mode is equal to write binary. So now at time of reading, we have to say read binary. First, we are opening a connection to that object. Having opened the connection, we have to run the load command. So when we say first is this opening connection, this connection name we have to type here in the load, and the sequence in which you saved the objects, the data structures at time of saving. For example, if you saved 3 objects, then the first time when you call the load function, the first object that you saved will get loaded. When you again call the load, the second object will get loaded. And when you again call load, the third object will get loaded. So if there are 3 objects saved in that particular Python object binary file, then 3 times you have to call load function to load the files. Okay. This is what all we had seen in our previous session also. So it's a repeat of that. So I'm going to run this syntax and load the objects. Syntax has run successfully, no errors. So I'm sure my df1, df2 and df3, 3 data frames would have been created because of this load syntax. Quickly try out in case you have not been systematically saving the objects, then note lrdf1 and lrdf2_n_3. These 2 objects are available on our LMS portal. You can download those, put it in an appropriate folder and run the syntax from there. Try out the syntax quickly. Okay, let us see whether our loading has been successful. So to see whether my file load has been successful, let me just run shape attribute and see. Okay, the first data frame which I have loaded has got 20,000 records and 8 columns. The second data frame has got or probably I'll run the print command. In that, I'll have both the shape coming together. The second data frame has got 20,000 records and 2 columns, and the third has got 19,000 records and 2 columns. In case you want to view the data, you can run head command. It will show the initial 5 records. Okay. Instead of running a view, say I would like to create a separate data frame. And in that separate data frame, I want to store the initial 10 records from data frame 1. So I have to specify the row index. So I'm saying data frame underscore 1 0:10. I'll get row index starting from 0 till 9. 10 will be excluded. If I run the syntax, I get this output. So here you can see we have got index from 0 to 9, which is 10 records. So this is selecting a few row by row index. Quickly try out the syntax. In the earlier syntax, we selected initial n records. However, many times our requirement would be to select rows based on certain criteria. We may want to apply certain filters. For example, I want to select records of all males in my database, or I want to select data of all females in my dataset, or it may be all male less than a particular age group. So you can have many conditions. So based upon condition, you can select certain rows, and that is called filtering or subsetting. Okay. In SQL language, you typically implement this filtering based on a where clause. Okay. In Python, the way you apply the syntax is, this is my data frame. On a particular column, I want to apply the filter. So I specify the data frame and the column name, and I'm using double equal to. Double equal to means equal to comparison. See, when you use single equal to, it is acting as an assignment operator. A equal to 10, which means I'm assigning value 10 to A. But when I say A equal 10, which means I'm now checking whether the value of A is equal to 10 or not. So here in this, I am putting the column and checking whether the value is M. The way it will work is, for each row, for the gender column, it is going to see whether the value or in that particular row for the gender column, the value is male, that is M, or not. If it is M, it will return a condition true, which means those row indexes will be marked as true. And whichever row index is marked as true will get selected. So I'll get the selected output I'll get in this data frame filtered df. So if I run the syntax, it gives me an output saying 14,279 records have been selected. Whenever you run these kind of conditions in data preparation, you have to be extra cautious. See, this one is a very simple condition. However, the way to work when you apply conditions, you should always cross check whether the output that you got is in line with what you expected. The syntax, the cross checking, the testing, whether my syntax is right or wrong, is never done by reading the syntax again. Like, okay, if I want to really ensure I'm writing right syntax, then I'll go through the code and then say, okay, my syntax seems to be right. No, testing has to happen through some other way. Now, the other way, you have to be innovative. What is the other approach? So one of the other approaches, basically you create reports, some summary outputs. So here I would like to see, on gender column, I'm running the value count function. Value count gives you a frequency. So in gender, whichever categories are there, for each category, it is going to give you the frequency, the count of occurrence of that category. So when I run the value count, it says M male is 14,279 and this number are matching. So I am sure I have selected all records which are male. Now, why this kind of cross check is required? Data is never 100% clean. It may so happen in gender column, male is somewhere written as capital M, sometimes it is written as small m, sometimes it is written as male, M-A-L-E, in caps, in initial M capital and A-L-E small. My condition was select all male. If data was not clean and male itself is written in multiple ways, with this syntax, I would not have been able to get all the required rows. How would I be very confident and ensure that I have written a right syntax? By doing a cross check. So by running value count, now I'm very clear there are only 3 distinct categories and the frequency of those distinct categories is given in the frequency value count. By comparing this value count with the output, I am confident my syntax is correct. Okay, so kindly run the filtering, subsetting and the value count syntax. See, this is a very simple example, but note, in practical life, when in industry, when you apply these filters for running, say, campaigns, the client would have given you condition. Client want to run a campaign, say in a banking example. Client want to run a campaign to sell loans. Now, when you sell loans, you typically do not sell loans to customers who are below 18 or below 21. Each company, each bank has its own threshold. Okay. Typically 2021 is the age when someone goes and starts working. So they do not target that segment. Neither they target customers above 58 because most of the time the retirement age is say 61. So if I target anyone above 58, the person will have only couple of years more to earn, and from earning only you repay the loan EMI, right? So they typically apply a condition saying age not above 58. Then when you run these campaigns, you don't run campaigns pan country. You run the campaigns only where you have your asset center. One is asset center, one is deposit. See, savings account, you can get money from anywhere. You have many branches. But to give loan, you require centers where someone can verify the loan applications. Many of the banks have moved to centralized, but still they require the machinery of collection team so that if in case a customer defaults, they should be able to collect. So they ensure they run campaigns only in those cities and those centers where they have got the machinery to lend. Okay, so they will apply filters based upon specific branches and specific cities. Likewise, they do not give loan to people whose income is below a certain threshold, and that income can be arrived based upon the savings account behavior. So now assume I have to run a campaign where I have been given the task of applying filter on age. I have given a condition to apply filter on city. I have been asked to ensure that the minimum balance maintained by the customer over last 1 year, average of last 1 year, is above say 15,000. In recent month, it can be 5,000 because now only the balance has gone down. That's why he requires or she requires a loan. But overall, over a longer time period, say minimum balance has to be around, average balance has to be 15,000. And then there can be many other policy cuts. So if there are 6, 7 policy cuts, I apply a condition: age less than 58, less than equal to 58, and age greater than 21, and city in certain set of cities, and balance greater than 15,000, and and like this I apply many conditions. If in this complex set of conditions, if one of the condition criteria I type wrong, what may happen? Wrong customer can be selected. Now, how do you cross check? Because the code would be a longish code. Now, how do you cross check whether you have written a right syntax or not? All the conditions which were given to you, specifically on all conditions, now you should run some kind of a quality QC report. For example, on a age, I can do a distribution. What are the ages which have been selected in the final cut? And condition was above 21 and 58, below 58. So all values should be between 21 and 58. If all the values I can see in isolation on that parameter, it is in the range, I know age condition was applied correctly. I can run a value count on city. Now all the city names that are coming is what was given as a filter to me, which means that condition was also applied correctly. So this kind of separate reporting should be done to cross check whether you are writing right code or not. See, syntax, one is syntax. Syntax is easy to learn, but ability to cross check whether the syntax I am writing correct or wrong is an important skill. So whenever you're working with data, you should ensure each step you do a cross check whether that step was done correctly or it was not done correctly. In the previous syntax, we had just applied one condition, which is on the gender column. In case we have to apply more than one conditions. For example, I am giving here example of AND condition. So here, if I have to apply an AND condition saying that I want to select rows which are age above 35. So what I am saying is I want all male who are above age of 35. So this ampersand is for AND condition. Okay. So if we run this syntax, and this entire part of the syntax you have to understand is in the rectangular bracket. This is one condition. What this condition is going to do is for all rows for each age column value, it is going to see whether it is greater than 35 or not, and based on that it will return true or false. And here for each gender column, it is going to return a value true or false, whether it is male or not. So this will return true and or false, and this will return true or false, and based on and truth table. And truth table is true and true is true, true and false is false, false and true is false, false and false is false. So wherever both of these conditions are true, those row indexes will become true and only those records will be selected. So if I run this, I get 8,348 observations. How do you again do a cross check? You have to run this syntax on the filter df, see what is the frequency of gender. Then you have to run this syntax. Instead of running on df1, you will have to run it on filter df, because in that filter data you want to ensure all values are above 35. So if you run that, by seeing the report you can say okay, condition met properly or not. Try out this syntax. Okay, instead of and, if my condition was I want to select all male or all customers whose age is above 35. In that case, what you will have to do, I leave it as a self practice. Okay, moving on, selecting specific columns. In the previous example, what we were doing is we are selecting rows. Now here we are seeing how to select specific columns. So let's see the first syntax. Here I want to select specific columns. I have given the data frame name, and in this data frame name I am specifying the names of the column which I would like to select. The names have to be, if there are more than one name, you have to put it again in a rectangular bracket. Basically you have to pass the column names as a list of column names. Okay, so if you run this, you will note that out of the 8 columns in df1, the 4 columns as specified has got selected. Just quickly run the syntax. Okay, now let us see the same syntaxes being written using iloc. In our previous sessions we have already seen that it is better approach to use iloc whenever referring columns, okay, or using loc. So let us see how we can write the syntax using iloc. When you use ilocs, basically I is for index location. So first parameter is a row position. So row position I have put colon, which means I want to select all rows. In the column position, the column indexes is put in a rectangular bracket. So I'm saying 0th index column, first index column, second index, and fifth index. And those indexes are actually for the same column, cust ID, target, age, occupation, where in the above syntax we had explicitly mentioned the column names. In this syntax we are mentioning these columns by the column index position. So if we run the syntax, we get the same output as we got in the previous syntax. So quickly try out this column index syntax also. Both the syntaxes are now available for you to compare and see. This syntax is going to give error. It is very obvious. When you have when you specify a data frame, you have got row position and column position. So there can be only one comma. You cannot have multiple commas. Basically here trying to represent 0th, 1st, 2nd and 5th index column, and that has to be actually in rectangular brackets. When you do not put rectangular brackets, the 0th is basically the 0th row, comma 1 would be the first column, then after that again comma is coming, 2 and 5 you will not be able to, the interpreter of Python will not be able to interpret it, so you will get a error. Okay, best approach is to use iloc. So whenever you want to select rows and columns, here in this syntax we are saying select from 0th till 15th. 15th would be excluded. Okay, and the column which are 0, 1, 2, 5. If I run this syntax, and the shape function is going to give me the details of what is the shape. It says 15 rows and 4 columns. In case we wish to refer the column by column names, okay, then we have the loc function. We have already seen that. Here 0 colon 15, though it is numbers, but please understand the index number also becomes the label name in Python, and here the label names are numbers. So basically you are putting 0 colon 15, so you are saying 0 till 15th row and the specific column. So this is the syntax using lock. Compare that to output, ilock and lock. Here we got 15 rows and here we got 16, because in ilock the 15, the end index is excluded, and in lock the end index is included. All of these things we had done in our previous sessions. So just quickly as a reminder, run these codes. Let us now understand the concept of data merge or data join. It is one of the most important thing that one has to understand when working with data. So before we get into what are the different types of joins or what are the different types of merge, let us understand why merge or join is required. These terms are interchangeably used. Merge and join terms are interchangeably used. Basically, both of them mean that you've got one data set, you've got another data set, you want to merge them or you want to join them and create a new data set, which is basically a combination of the two. Okay. Where is the requirement where you come across the need of data merge? First, assume you've got a customer data, you've got account data. So you'll have a customer master. Customer master by logic will have to capture all customer related demographic details. When you say account master is supposed to capture the type of account, the type of product you buy. Okay, so one customer can have three different types of account. In case of banking, it can be a savings account, it can be a fixed deposit account, and it again can be a fixed deposit account. I open two fixed deposit you open, you get two fixed deposit account, right? Now I want a data set. Typically whenever you do analysis, what you want is all attributes to be available in a flat file format, in one file. Basically, when I say flat file, what I mean is in one long table you want all attributes. So all attributes of the customer and all attributes pertaining to account I want in one row. I don't want it to be in two different tables. So in that case I'll have to merge, right? Now comes the concepts of what are the different types of merge. So we are going to see it from two different perspectives. One is the kind of join that we are performing, okay, and second is again based upon the cardinality of the identifier column. You have got different kind of output. That is second part I'll explain separately. Here first let's see type of joins. I have got a table. In this table there is a identifier column. Typically whenever you merge, you require at least one column which is common across the two tables. So let us call this as an identifier column which is in table 1. And then you have got another table or another data frame. Table is from a SQL syntax. Here we call it as again this identifier column. Assume this table is about data of customers to whom you sent the survey. You are doing some survey. This table is related to customers to whom you have sent the survey. Okay, and this table I'll name it as S, and this table is basically the feedback or the rating which the customers has given. I hope you understand that if you are sending survey to 10,000 people, all 10,000 do not give feedback most of the time. It would be very rare that all the 100% of people are going to give the feedback back to you, right? In the positioning, in the diagrammatic view, one of the table is in the left hand side and one of the table is on the right hand side. Okay, so let us call the S survey table as left hand side table and the feedback table as the right hand side table. That's a terminology. Okay, now if I join these two tables, the way I'm joining these two tables is in the outcome. In the outcome, I want all records from survey and feedback table where the identifier was matching. Where the identifier was matching, which means here only those records should be there of customers who are present in the feedback table and customers who are present in the survey table. Common identifiers. That is called inner join. That is called inner join. Typically, these things are represented like this. If you try to search about this join concept, it would be represented like this. The intersection, the identifiers, the records which are common across both the table, when you are retaining only those records in the outcome, it is called an inner join. In case I want the outcome such that I have all identifiers here which is present in this table and all identifiers which are present in this table also. Okay. Now let us say this feedback which you have collected has been collected based on particular time period. You sent this survey on 5th of March. This was sent on 5th of March. A particular survey sent on 5th of March is what we are considering. But here the feedback is being collected for the entire month of March. Probably it has got some feedbacks which are from past survey. Okay, which means here you will have certain identifiers which are not there part of the survey sent on 5th of March. And obviously all customers to whom you sent a survey on 5th of March will not be present in the feedback in the month of March. Do you agree? Now if you are merging these two tables such that irrespective of whether the identifier is present here in the left table or whether identifier is present here in the right table, all records are now in the outcome. That is called full outer join, which means what you are doing is you want to select all observations which are part of both the tables, this table and this table. So outer boundary, everything which is present in both the table is what I'm going to consider as part of my final outcome. That is called full outer join. In case I put a condition that this output table should have all records from the left table, irrespective of whether it finds a match in the right table, which means in a right table I don't find the feedback of a given customer, but still in the output I am taking that customer. That is called left outer, which means my focus now, I'm not getting the color palettes. Okay, I am taking all records of the left table and the corresponding information wherever the identifier match is there from the right table, I'm going to put that information also in the output. That is called left outer. The reverse of left outer is right outer. In right outer, what I am saying is I want all observation of the right table to be in the output, irrespective of whether the corresponding identifier matching in the left table is present or not. If it is matching, then get that attribute from the left table also. But if it is not matching, put null values. So in that case, this would be a right outer join, where the focus of right outer join is this one. So let me put a more zigzag line. If my outcome is focused here only in the right table, everything has to be there. But from left table, whatever attributes I get for the matching identifier, I'll pick that and keep it in the output table. That is called right outer join. Finally, a join which you should never do is called a Cartesian join. What a Cartesian join means. Let me erase this ink. There is a left table which has got identifier 1, 2, 3. There is a right table which has got identifier 1, 3, 5. You are trying to merge them. You are not saying I want to merge which column by which column. See, tools like Python and R, sometimes they act intelligent. If you do not specify the column by which you want to merge, it automatically tries to find which column name is common. And then they understand, okay, these two columns are the by which they have to match. But assume here you have given the column identifier column name as ID, and here the identifier column name is called IDD something, some other name. The column names are not matching. Now the intelligence of the tool is also gone. You have not specified by which condition to merge. The outcome will be a Cartesian join. Cartesian join means now this row will get merged by this. It will get merged by this also. It will get merged by this also. So one row of the left table will merge with the 3 row of the right table. You get 3 outcome. This will get merged with this. This will get merged with this. So second row will also get merged, and third row. So in effect, you will end up M cross N records. Assume you got 10,000 records here, another 10,000 records here. It would become 10 CR. That is huge records unwantedly. And before you get the outcome, your system is going to say ran out of memory. Okay, so Cartesian join to be avoided. You should always ensure you specify the identifier column when you are doing a merge. Okay, this is the different types of joins or different types of merge. There is another way of looking at merge also. Let us try to understand that. There is a customer table, and I was mentioning about the banking example. There is an account table. In a customer table, a customer ID is going to come only once. But in an account table, a given customer can have multiple accounts. I'm just naming A1. A1 is account 1 and A2 as account 2. The point I'm trying to make is here if I merge these two tables, the merge will be called as one to many. Because one row of the table 1 left is getting merged with many rows of the table in the right. So this is called, from the kind of a cardinality point of view, it is called a one to many merge. If I place the account table on the left hand side and the customer table on the right hand side, and now I merge it, it will be called many to one. If I am merging two tables such that the identifier column in the two tables are unique, which means here one is coming only once, and in this table also one is going to say come only once. So you will not have one repeating or any identifier in a table repeating. If you are now merging them, it is called as one to one merge. Most often when you are working with data, you will come across one to one merge and one to many merge or many to one merge. Now let us consider example or scenario where you have got a table where the left hand side table has given identifier repeating many times. The right hand side table also has the identifier repeating many times. And now if you are doing a merge between these two tables, it will be called as many to many merge. And any given point of time when working on data, if you come across a many to many merge, you should understand you're doing something wrong. The moment you are coming across many to many merge, you have to understand you are doing wrong. Okay, because data normality, data is stored in systems using some normalization, and when you're doing some normalization, this kind of a merge, you will find it will lead to absurd output. There's only one place where in my experience we had to do many to many, and that is when you are doing data deduplication. When you're doing data deduplication, you've got one table here, you've got another table here, and you're now trying to find which records are duplicates across the two tables. Only there, many to many merge is what I have found is allowed. Otherwise, in data analysis, many to many merge, the moment you see there is a many to many merge between the two tables you are working, or the two data frames that you are working, or the two data sets that you are working, you have to understand you're doing wrong. Okay, so this is a quick overview on data merge, data join concept. Now let's move towards the syntax. How we go about writing the syntax of merging. The way the syntax is written, you have to use the pandas library. So here PD is to represent pandas, merge function, and then you have to specify a data frame and a second data frame. The data frame which is mentioned first in the order automatically is considered as the left data frame. The data frame mentioned second in the order is considered as the right data frame. Then you have to specify left on. In the left data frame, on which column you would like to consider it for the merge. So you have to specify the identifier column of the left data frame. Right on, you have to specify the identifier column from the right data frame. Left on and right on. The reason why they have given two attributes, for example, if the identifier column in the left table is named as ID and the identifier column in the right table is named as IDD, in that case the names are different. So you will have to specifically say left column ID has to be merged with based on right column IDD column. In case you are confident that the identifier column in both the table is named correctly and same, use on. Don't bother about left on and right on. Okay. How you would like to merge? I would like to merge as a left join. I would like to merge as right join. I would like to merge as inner join, or I would like to merge as outer join. Okay. So this is the syntax. So here we are going to create sample data frames so that you can see the observations instead of using our df1, df2 and df3, because they have got 20,000 observations, 19,000 observations, will not be able to visualize things. So I'm creating a sample data frame so that when we merge, we are able to quickly visualize the outcome of the syntax. So here what I'm creating a data set 1, where I'm creating 5 rows and I'm giving the values as 1 2 5 6 8, and again the second column where the values I'm giving A B C D E. Index, the first column I'm saying ID and the second column I'm saying alphabet. Likewise, I'm creating another data frame with 5 rows where the sequence is 1 2 3 4 5 is the ID values, and the second is apple, bat, cat, dog, elephant. Okay, so the two data frames I'm creating, this is the outcome of the two data frames. So let's run the syntax from here on and see whether you get the DHT1 and DHT2 output. Just quickly try out the syntax. Okay, so now let us see the merge syntaxes one by one. In this syntax, we are saying DHT1 and DHT2 to be merged on ID column. How is equal to inner. So let us just go up. So DHT1 has got identifiers 1 2 5 6 8. DHT2 has got identifier 1 2 3 4 5, and we said inner, which are common. 1 2 is matching and 5 is matching. So the output should have 1 2 and 5. Yes, if I run the syntax, I get the output having only those rows where the identifier in the two table is matching, which is 1 2 and 5. Opposite of inner is outer. If I say how equal to outer, in that case, when you execute the command, you see all of the matching ones: 1 2 5 6 8 3 4. First, all the records from the left hand side table has come 1 2 5 6 8. The records of the right hand side table which were not matching has now come 3 4. And note, 6 is present in the left table but not in the right table, so it has put NaN. Here also NaN, and here for 3 that there is no corresponding identifier 3 in the left table, so it has put NaN. Okay, so this way you can understand the difference between the inner and outer. Outer is all records from both the table to be in the output data set. Inner is common identifiers from both the merging tables to be in the outer data set. So quickly try out the inner and outer join. Now let us see the usage of left and right. We are just changing how in the syntax. So you can copy paste the syntax from the previous cell, and according to that I have renamed outer as left outer. So here, the moment I say left outer, all rows from the DHT1 is now in the output. In DHT1 we had identifier 1 2 5 6 8. I want to quickly check. So I see, okay, DHT1 1 2 5 6 8 were there. 6 8 is not present in DHT2. So what happens is all rows of DHT1 is in the outer left outer table merge. Wherever the corresponding value was not matching from DHT2, it is just put NaN. The same syntax, let me just execute this. Yeah, this syntax I've just changed left to right, and here you can see all observations which are there in the right table are present. The corresponding left table where the identifier is not matching, it has just simply put NaN. So let us run this syntax also. So these are the two syntaxes on left and right outer joins. Okay, let us just quickly run the syntax without using the on. If I just delete the on and also I exclude how. Now I'm not going to specify how it has to merge. So if I do not specify a how, it by default goes to inner. So here I should actually not name it as dst underscore merge. So if I do not specify how, by default it has gone to inner, but it has smartly identified the common column between the two data frames. Okay. So we have done with the basic merge syntaxes. The entire objective of doing that basic merge syntaxes was to ensure we can now merge our three data frames. So we had data frame 1, data frame 2, data frame 3. So here the syntax is, I'm saying df1. Note the difference in the syntax. Here I was calling the syntax as pd.merge, the merge syntax of pandas function. The merge function, the other way is I can specify df1. Why? df1 is an object of type pandas. Pandas is a class. df1 is an object of class pandas, which means all functions in that pandas is now available in the data frame object. So I can call this syntax this way also. df1.merge. The moment I call df1.merge, the data frame through which I am calling the function merge becomes the left table, and the second table is what I specify here becomes the right table. On equal to cust id, how is equal to outer. Now why I am writing outer, let us recollect. df underscore 1 dot shape comma df underscore 2 dot shape comma df underscore 3 dot shape. All of these three things will not get printed, so I need to put it in a print function. df1 and df2 has got 20,000 observations, df3 has only 19,000 observations. The dataset, the way it has been given to you, the identifiers, the cust id column has got values c1, c2, c3, c4 till c20,000 in df1 and df2. In df3 the values are c1, c2, c3 dot 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 till c19,000. So c19,001 is not present in df3, c19,002 is not present in df2. Okay, that's how the data frames are. So here first step what we are doing is we are merging df1 and df2. I'm saying outer for the first merge where these two has got same customer IDs c1, c2, c3 till c20,000. Whether you specify outer or inner is not going to make a difference because customer ID is present in both the table. So both of them are completely overlapping each other. In this case, outer and inner is same. What I'm trying to say in a pictorial depiction, this is df1, the cust IDs, the set of cust IDs in df1, and the same circle is the set of customer IDs in df2. They are completely overlapping each other. That's why inner and outer actually same, right? So here whether you specify outer or whether you specify inner will not make a difference. Where it is going to make a difference when you're going to merge this one. Here if you specify outer, you will get 20,000 observations because 19,000 identifiers between these two are matching. There are 1,000 identifiers here which are extra, which also will be out in the output. But if you say inner, what will happen? It will lead up to 19,000 records. So let us just quickly see. I'm going to run the syntax. First, I'm going to run this syntax with the outer, and I don't require head. I can comment head. So I'll run the syntax with outer. So you can see 20,000 observations and 10 columns. Why 10? There were 8 columns here. Here 2 columns are there, but one is identifier, common, matching. So there is only extra one attribute. And here again there are 2 columns, but one is common, matching attribute, which is identifier, and another attribute. So 8 and 2, 10 columns will be there. But if I run this syntax by inner, this would become 19,010. Why? There are 19,000 observations. I said inner, common is what I want. Okay. So let me rechange this code, because going forward we'll require the data set with 20,000. But for your own learning, for typing, try out all these syntaxes. From merge, we now move on to the next topic, append. Basically, merge means merging of columns. Append is basically putting rows, adding rows, combining rows of one data frame with another data frame. Okay, so let's see the syntax for append. Append is adding records of one data set below the other data set, and the function is very simple. You have to say append pandas dot append. So here dst1 dot append dst2. Sort is equal to false. This is what you have to give the option, sort equal to false, because if you don't give the option, then it will keep getting a warning that you have to specify the sort. Okay, let us run the syntax without first resetting this part of the syntax. So I'm simply appending and displaying the data set. So here you see the ID columns 1, 2, 3, 4, 1, 2, 5, 6, 8 of the first data frame, and then 1, 2, 3, 4, 5 of the second. Here alphabet column is not present in the second data frame, so all values become nan, and animal column is not present in the first data set, so all values it becomes nan, and in output you got 3 columns, which is a combination of all the distinct columns present. ID was common column, so the values went one below other. Where the column names were not matching, it created additional columns, right? And the rows where the value is not there, nan. Note the index 0, 1, 2, 3, 4. The first data set has got the index as 0, 1, 2, 3, 4. In the second data set, the index was 0, 1, 2, 3, 4. So index is repeating. Okay. In case I want the index to be continuous 0, 1, 2, 3, 4, 5, 6, 7, 8, in that case I'll have to do resetting of the index, and when I say reset index, you have to say in place equal to true, which means you are changing the same data set. Resetting has to happen on the same data set. Okay, drop equal to true. So if you run this, now you see the index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The index, earlier index gets dropped, new index gets resetted, and it is done all on the same data set, which is dst append in this case. So now try running the syntax with reset index. Let us now see how to rename columns. Before getting into the syntax, it is important to understand that appropriately naming the column is important. So rename syntax is very useful just in case while working on data you have not aptly named a column. It is the best practice that the column should be renamed and given an apt name. Let us take an example. In banking, typically there are 3 transaction dates, 3 types of transaction date. One is called a transaction date, second is called a posting date, and third is called a value date. Transaction date is when the actual transaction is supposed to happen. Value date, many a times the effect of the transaction is given today, but it should be really in effect in past, historically, or in future. In that case, you have got a value date. And third is posting. Most of the times what happens is salaries which you get on 31st or the 1st of the month by a company on a particular day. If the salary has to come, say, on 1st of the month, it is not that the company uploads the salary detail on 1st. Typically, the data of salary to be credited in each employee's account is uploaded on 31st. That date becomes the posting, the end of the month. That date becomes the posting date. But effect is given on 1st. First now becomes the transaction date and first becomes the value date. So you have three types of date. Assume you are designing a database table and you name the column as date 1, date 2, date 3. Now, will you be able to say which date 1, whether date 1 is a transaction date, value date, or a posting date? No. So this column is not self-explanatory. In that case, if you would have given the column name as txn underscore date, value underscore date, post POS underscore date, it would be self-explanatory. So giving appropriate column name so that the column itself explanatory is important. So the rename syntax, don't try to learn rename syntax only from a syntactical point that how to go about renaming, but see the importance is if a column in my analysis, in my data structure, in my data frame is not aptly named, then and there I should be able to recollect that, hey, renaming of column is possible and I should rename it. Okay. So here the syntax rename is very simple. You specify the data frame dot rename function and columns equal to, then you open the braces. Braces is basically used when we create a dictionary. Dictionary is a key value pair. So in a braces you provide old name, new name. So old name becomes a key, new name becomes a value by which you want to replace the old name. So you provide all of these renaming columns in a dictionary kind of thing. In place, again you see the in place equal to true syntax. In place equal to true means you change the data frame. In the same data frame you have to make the change. Otherwise, in place is equal to true is not written. In that case, what will happen? This code will run. A new object will be created in memory. And no one is now pointing to that object. No one is there now pointing to that object. Otherwise, the syntax would have to become, say this DHPD is some data set, name of a data set. Then I'll have to write the syntax like this. If I don't write in place equal to true. Why? Without in place equal to true, a new object is created in memory that from this rename function. And then I'm assigning it to DHT, which means the original DHT which was pointing to some object, now the pointer will move to the new object. But without writing this syntax in this format, by just saying in place equal to true, what you're saying is, I don't need this part of the syntax. So it eliminates the requirement of writing DHT equal to that something. Okay. So here first what I'm going to do is I'm just going to see df where we created df. We created df in our merge syntax. When we merge the data frame 1, data frame 2. So df we have got a shape of 20,000 rows and 10 columns is where we created df. So first I'm going to just quickly see after having merged all of them, what are the columns? So the set of columns, when I run that command, it says cust ID, target, age, and so forth. Most of the column names seems to be well defined, properly named, appropriate. By just seeing the column name, I can understand it. Only now from a syntax point of view, for explanation, I'm just going to say, okay, let me change SCR to score. Okay, in place equal to true. Once I run this rename syntax, now you see This column has become score. Okay, so this is the rename syntax. Just quickly try out the rename syntax. We now see another important data preparation step, which is data sorting. We require sorting many a times. Let's see practical example first, and then we'll see syntax. Assume I want to buy ticket, airline ticket. So I go to some airline portal and I give my origin, destination, date of travel, and basic other details. It will display a list of airlines and the various flights operated by them on that route. And by default, the data which is presented is sorted by price. Now, what if my objective is not low cost, but my objective is to take a flight at a particular departure time? In that case, what I'll do, I'll sort it and see the data sorted based on departure time. Or if my importance is duration, there can be a non-stop flight taking 2 hours and a one-stop flight taking 3 hours. So there are many flight options. So if my choice is duration, so I'll sort it based on duration. So point is, many a times when you view data, it becomes very important to sort data and move important data points either up or down. And that's where sorting comes into play. Okay. So the approach or the syntax to sort in Python is use sort values. You sort based on the values, right? So the function is sort values. Values based on which column? So you have to specify the column names. In case you wish to sort it by only one column name, you can specify only one column. But if you want to do multi-level sort, in that case, you have to specify the second, third, fourth column also. Okay. The way multi-level sort works is first the data set will be sorted based on the first column. Now, many records has got the same value of age. In this case, the first column is age. So I've got 20,000 observations. Assume 2,000 observations has got the same age of 21. Within these 2000 observation, I want a second level sort which is based on holding period. So it will apply not just for age 21, but it will apply to all the age buckets, right? So that becomes the second level sort. It can go third, fourth, n level. So that is called a multi-level sort. Now I want sorting ascending or descending. So if I say 1, it means ascending. Ascending means lowest value will be at top and highest value will be at bottom. In case I say 0, so which means here I've passed two columns. So 1 will apply to age, 0 will apply to holding period. So I'm sorting ascending by age and I'm sorting descending by holding period. The second level within age, it will be sorted by holding period in a descending order. So if you run the syntax, you see 21 is at top. I run head. Out of 20,000 observations, the initial 5 you see are 21. If I run the tail command, you see the bottom 5 records are 55. Okay, so it is basically sorted ascending by age. Now within age, or probably I can do some 100 here. Okay, so age 21, 21, 21. Now within age, the second column is holding period. So initial, because it is descending, 31, then 29, 28, 27, 26, 25, and so forth. So this is ascending, descending sort and multi-level sort example. Let me change it back to the default. Yeah, so here you got the sort command and head and the tail function to see whether the sorting has happened properly or not. Yeah, just try out these syntaxes. We now move to an important concept, which is aggregation. Before we get into aggregation and the syntax, let us understand a very important concept of aggregation. Whenever we do data aggregation, you have to understand data from a reporting sense. If you try to see data from a reporting sense, it has got two elements. One is called a dimension and second is called measure. What is a measure? Anything that you can measure is called a measure. So I've repeated the word, anything that you can measure is called a measure. For example, how many liters of fuel you refill? You can measure it in terms of liter. How many kilometers you have walked in the day? You measure it in a kilometers. Anything which is measurable is called a measure. What is dimension? Dimension is something by which you would like to aggregate. For example, you have got 10 stores. Those stores are 3 are in the state of Maharashtra, or let's say 3 are in West region, 2 are in North region, 3 are in East region, and 2 are in South region. And each store is doing retail business. So what you will have? Sale. Sale is a measure. Why? Because you can measure sale in terms of rupees. But I, as a manager, would like to see report sale by region. Can you measure region? No. You can see a number by region. So in that case, region becomes dimension, right? Let's take another example regarding related to store only. You are having 3 different sections in each store. One is a apparel, second is electronic, and third is basically staples, day-to-day food items. Now what you are going to see report? Sale by department. Can you measure department? No. You can see some metrics by department. So department becomes a dimension. Sale become a measure. You can have another metric, number of items sold, number of customers who came to purchase in each department. These are all measurable. But you are seeing this by, anything which comes after by actually becomes a dimension. So you will see sale by geography. You can see sale by time. You can see sale by product. You can see sale by customer segment. You can see count of customer by geography. You can see count of customer by product. You can see count of customer by time. You can see count of customer by customer segment. The term which comes after by is actually a dimension. And what you are trying to quantify is actually a measure. So this is the concept of dimension and measure. So whenever you are aggregating, you have to understand, I am aggregating at what level, by what, and by what becomes your dimension. Okay. There is one more concept within dimension which is called hierarchy. At this point, at a very high level, I'll give you a concept of hierarchy. Now when I am measuring sale by time, that time can be an year, that time can be a quarter, that time can be a month, that time can be a week, that time can be a day. Day gets into week, week goes into month, month goes into year, month goes into quarter, quarter goes into year. So there is a hierarchy. The lowest granularity is day. So a dimension has got sub levels, and that hierarchical sub level is called hierarchy. Okay, so that's on dimension, measures, and hierarchy. Now the thing is how to see certain number by a dimension, and that's where aggregation comes into play. Okay, or many times you want to see reports. Report is basically a summarization. Summarization means aggregation. Okay, so let's see the steps. Now when you're aggregating, grouping, or summarizing, first step is you have to say group by what. You would like to do aggregation by what. So here in our data set, I'm saying df.group by gender, and this I'm storing in a variable, object by the name gr_by_object. I'll read it as group by object name. Okay. The moment you run this syntax, what it does is it goes into data frame and finds out what are the distinct categories of gender, distinct levels of gender. So there are three values M, O, F. So those three now becomes the keys of the group. The categories of the column here actually means dimension. The categories of the dimension gender becomes the key. So if I now try to print out, it says the dictionary keys are M, O, F. In case I want two dimensions, I want to know sale by geography and product. I can say report by two dimensions also. I can see report by n dimension also. In case I want to do it by two dimension, the set of dimension I have to put in a list, rectangular bracket. In the group by function, I have to pass it in a rectangular brackets. So here I am saying I want to see it by gender and target together. So now the keys becomes O and 1, that is other and 1, F and 0, then O and 0, M and 1, F and 1, M and 0. So basically there are three categories in gender and two categories in target, which is 1 and 0. So 3 into 2, 6 combination. So you got 6 dictionary keys. Okay. Step 2. What aggregation, what measure you would like to see? The common measures are count, sum, min, summarization, min for minimum, max for maximum, mean, that is average, arithmetic average, mean, median. Those are the common standard aggregations. Okay, so here what I am doing is I am taking this first object. Second object will override. So I am taking actually the second one. So I am saying that by this gender and target, I want to know mean age, I want to know min age, and I want to know max. So here what you have to do is, let me run this first syntax and second syntax. So the second syntax, because we are overriding the group by object by the second, so this is what is going to apply. On this object, I'm saying I want to do the aggregation. Okay, because it has already given me these keys. So at this level, what values I want? I want the mean age, min age, and max age. So on age attribute, I want these three elements. On balance, I want a summation. On customer ID, I want count. Why customer ID I want count? Because customer ID is C1, C2, C3, C4. Can you add them? No, you cannot sum them. Can you find min? No, you cannot min, right? So I want just a count. Okay. So when I run this, it is going to generate values which are going to be of that type. Let us remove this comment. Let us remove this part so that you can see the output, what it is going to do. When you run this, you get this kind of out. Age, mean, age, min, age, max, cust ID, count, balance, sum. And here you see gender and target. In gender F, there are two levels of target 0, 1. In gender male, there are two levels 0, 1. In others, there are two levels 0, 1. So it is now given female 0, mean age is 37, min is 21, max is 55. Count of customers who are having gender female and target 0 is 5345, and the total balance of these people is around 1.07 E09. That is 107 crores something. Okay. So this is the kind of output. But here you see this kind of output, two rows. There are two rows, right? If I want to make them in one row, the column headers in one row, basically what you have to do is ravel. Ravel means converting things into a single row of columns. The moment I run this ravel function in a loop, for each column I am running a loop. Some of these syntaxes may not be easy to understand. So what you should do is you should remember where you have this syntax. When you use it in future, you should be able to use it. Over time, with practice, you will come to know the syntax meaning. So at this point of time, I'm not going into the syntax explanation for this particular row. But what I'm trying to do say is it is going to convert this age, mean, which are in two rows into one row of columns. That is what a ravel function is going to do here. So now if I run the syntax, you see it becomes like a one row of column names, right? So this is the aggregation step. So whenever you do aggregation, first you have to conceptual level understand that there has to be a dimension, there has to be a measure. Once you have understood that, then you have to specify, I want to group by what? Group by what? What is your dimension? Having specified by what you want to aggregate, then you have to specify what aggregate values I want to have. That are basically the measures. And this is the syntactical way of specifying each measure what statistics you would like to have. Okay. So quickly try out these syntaxes of grouping / summarizing of data. Let me scroll below. Okay. So we just did aggregation. We are now going to see how to go about doing aggregation using SQL syntax. Before I get into aggregation of SQL syntax, I just gave an example of hierarchy, time dimension. Time dimension, I said year, quarter, month, week, and day. Week actually is a mistake. Why? A day can roll up into week, but week cannot roll up into month. There can be a week which is partially in one month and partially in another month. So when you are doing an aggregation, the roll up is important. What can roll up into the above hierarchy? It has to be properly taken care. So the hierarchy of time actually would be year, quarter, month, day. It cannot be week in between. I hope you understand, right? So that was a small correction I wanted to mention. Now coming back to the SQL syntax execution using uh, aggregations using SQL syntax. So this is for the people who are aware of SQL. Most of these data management tools provide SQL query execution functionality. The reason why they provide SQL execution functionality is many people working on these tools are actually also familiar with SQL. So at times, if they want to do aggregation and they are comfortable with the SQL syntax, then that person may want to execute aggregation by SQL query. However, here I would like to mention a specific experience I had. We were working on a data set having around 60 lakh observations. That was at a customer transaction level. So which means it was transactions of customer. Just like you open your bank account, you will have 10 transactions in a given month. So it was that kind of a data. Our objective was to summarize at a customer level. How many credits, how many debits, how much inflow, how much outflow. That kind of aggregation we were trying to do from transaction at a customer level. Our initial attempt was to run a SQL syntax using Panda SQL functionality. That query was taking hours to run. Then we changed the code using the aggregation syntax, which I just explained. That query of aggregation syntax of Python executed within 2 minutes. The point I am trying to make is the native syntax of Python, which we just saw in the above statement of aggregation. This one, using first creating keys by group by and then creating the summarization measures, is much more faster than using a Panda SQL in Python. So this should be used only as a convenience when the data set is smaller, is my recommendation, or probably my recommendation based on my personal experience. Probably at that point of time I might have done something wrong, but in that entire project multiple places we have tried out and we found that aggregation is much more better and a faster compared to running a SQL syntax using Panda SQL library. Anyways, for the objective of learning, let's see the syntax. So here I'm using Panda SQL. I'm giving alias PD SQL. Now what query? What is the aggregation that I want to do? First, what I'm saying is select. You have to specify the dimensions. So I'm saying select gender, comma target. Then I'm saying average because I wanted to have the mean, age. So I say average is the function. In SQL, you don't have mean, you call it AVG. So I say average age, then I say min age, and this as is basically I'm renaming. I'm not renaming, I'm giving a name to whatever is the summarized value. So min age as age min, max age as age max, sum balance as balance sum, count one as CNT. From where? From this data frame. When you write this syntax, these are dimensions, but you have to specify at bottom once again, group by the dimensions. Anything where you use aggregation function like average, min, max, sum is automatically understood it is a measure. When you are using average, min, max, you have to have number column only. But when you are using count, in count I could have written it like this also. It's okay. Because what it is going to do? It is going to count the number of number of rows in which customer ID value is present and it is not empty. It is going to count only those. Okay. But the simple approach is when you really want a count, why not put one? Number of rows which are there with this combination, you count them each of them one time. So count of ones will be, that is the number of records. Okay. The other approach of, instead of putting one, is many people use star. Also acceptable practice. Okay. For more knowledge on SQL, you can go online and try to develop your SQL skills. One of the website particularly which I find good is W3 Schools. Okay, so you may see that website and develop your SQL skills. So here what we have done is we have just created the query string. It is still a string variable, and again, if you recollect your string syntaxes in Python, the SQL syntax is running in multiple rows. SQL syntax is running into multiple lines. As such, you cannot write this syntax like this with single quote. If a string statement runs into multiple lines, in that case, you have to use 3 single apostrophes, or you have to run 3 double apostrophes. Either of them is okay. I hope you recollect based on our initial day 1 session where we learned basic data types. If a string statement runs into multiple lines, you have to put it in 3 single quotes and 3 double quote. Okay, that's a statement. Then you have to call the SQL df function. Panda SQL df function, you have to pass your query string. Whatever is the output of the query string will get stored in SQL query output, and then we are just printing it. So let's run these two syntaxes, and this is the aggregated output. Currently we are running aggregation only on a smaller data set, 20,000 rows. That's why you are not able to differentiate the impact between running the previous aggregation syntax and this. This impact will be much more clearly visible when you run it on larger data set. Just try out this syntax. In case you find no module Panda SQL name such kind of an error, in that case you will have to run Anaconda command prompt. You will have to open, run as an administrator. In an administrator mode, you may then have to run conda install Panda SQL. In case I run it now, it may not install because the library is already loaded in my memory. Okay, just in case you find this problem, then you will have to install that library. So let me just execute. So it's now trying to solve the environment. So once it has detected the environment, it gives me a warning message. New version is available. Please update Conda by running something. And now it is asking me whether I want to install the updated version of Panda SQL. For now, I'll say no and exit. In your case, you have to say yes if the library is not installed. In that case, you have to type yes. Why? So exiting. I hope the conda install Panda SQL command resolves the error. Once you have done the installation, you rerun this import step. It will load the library, and then you will be able to call the SQL df function of Panda SQL. From data aggregation, we now move to another concept, which is dummy variable creation. It is also called as one-hot encoding. Let us try to understand what is one-hot encoding. Many of the machine learning algorithms, specifically the algorithms that you find in Scikit, which we have already seen when we went through library, package, module understanding, we used Scikit. Scikit is scientific kit, right? So many of the algorithms, when you work with, it requires the values. All values should be numeric. It cannot handle columns which are categorical. Now, gender, for example, is a categorical where you have got male, female, others, or occupation, salaried, self-employed, unemployed. Those are categories. If that is the kind of column that you have, in that case, you have to convert it into dummy variables, or what is also called as one-hot encoding. What it means is, for example, before running the code, because it's already there in my screen, for example, occupation is a column. It has got values as salary, professional, and so forth. This occupation should get converted into column. Occupation prof, occupation sal, occupation self-employed, such that if a customer belongs to a salaried class, in that case, that column should become 1 and other occupation category column should become 0. If a customer belongs to a professional class, in that case, a professional column created, occupation profession, that should become 1 and other columns should become 0. So what will happen is, in a dummy one-hot encoding, let's take gender example. It has got male, female, others in our data. When you do dummy one-hot encoding, it is going to create 3 columns: M, F, O. You can have prefix or you can have suffixes. So you can say gen underscore M, gen underscore O, F, gen underscore O. So you can have some prefixes so that the column names don't match with other existing columns. Okay. Now, if a particular row has gender male, in that case, gen M, gender male, column should become 1. And gender female and gender other column should, row value should become 0. Okay. If a particular row has got the value F, in that case, gen M column and gen O column should have the value 0. Gender F column should have the value as 1. So that is called as dummy one-hot encoding. It is very easy to do dummy one-hot encoding. You have to call getDummies function. And you have to specify the column which you want to you have to specify the column for whose categorical values you want to convert into columns. So I'm said occupation. These are my categorical values in the occupation column. They will now become column names. Prefix by OCC. Okay. So once this new set of columns is what I get, so what I'll do is, first I'll run it in 2 steps. So first I'll run only this step. These are my dummy one-hot encoded new columns. But where do I want these columns? These columns I want in my existing data frame. If I want it in my existing data frame, in that case I have to write further lines of code. So I can now comment it. I want to concat. Here we are not doing merge. Please understand, we are not doing merge. Actually I'm merging, but we are not using the merge function. We are using the concat function. If you use a merge function, it requires an identifier column, the on column. But I don't have the identifier column in this case. So here what we are doing is concat. The concat is actually working like a merge only. Only what it is going to do is going to take the first row of the data frame you have specified first. It will take the first row of the second data frame, which is OCC underscore dummy, and just concat them. So row by row concatenation will happen. And that's what we want because the sequence is same in both the data frames. Axis. What is axis? I'm merging it by merging the rows. Okay. So axis is equal to 1. So if I run the syntax, the dummy columns goes at the end because they have concatenated at the end. Make sense? So try out this. Once you have done this occupation, gender syntax you have to write in the classroom. That is a practice, immediate practice assignment. Okay, first do it for occupation and then try it for gender. Okay, we now move to the last element, which is called casting. Converting column data type from one type to another is called casting in programming language. Here I am saying A is equal to 10, B is equal to 20, C is equal to A plus B. I say print value of C is, and then the C, the variable C, which I want to print. Here plus B, the moment I see plus, I understand, I feel it should do mathematical operation of plus. However, plus is also a concatenate function. Basically, concatenate means you stick two values to each other. That is concatenate. So plus is, if you pass numeric values, it will do addition. If you pass string value, it will act as a concatenation. So in this case, when you print, you see value is equal to 1020. Mathematics has not happened. Concatenation has happened. In case I want to do mathematics on A plus B, what I have to do is I have to first convert this string into number. And here the value 10 can be casted. When I say can be casted, it means it can be converted from string to numeric type. If the value of this would have been something not 10 but AA is definitely character, which means it cannot be converted to integer. So whenever casting function is used, that is a conversion function is used, you have to see whether the value which is stored in that variable, can it be converted into the other type or not? Is it feasible? Only if it is feasible, then you can use the casting function. Okay. So here I am saying int a. Int a, the moment I say int a, which means it gets converted from 10, which is stored as a string, to numeric 10. And here I say int b, which means I'm saying convert the value 20 in variable b to numeric 20 for the calculation purpose. And if I run this, I'll get value of C. Name A is not defined. Why? I think I did not execute this command. That's why. Yes. So C is 30. Okay. Converting value of a particular variable or a column from one data type to another in programming language is casting. Now when I say print value of C is, again error. Why? This part is string. Plus either it will do numeric addition or it will be doing concatenation. One of the element here now is string, the other element is number. If it sees string, it thinks I have to go and do concatenation. When it sees number, it feels I have to do addition. Now it is again confused, right? So now it does not know what to do. So it will go based on string function. But the moment it goes into string function, it sees integer. So it cannot concatenate. Some programming language do auto casting, auto type conversion. What I mean is, some programming language, when you see this kind of a syntax, if it understands that, hey, you want to do mathematics, automatically it will convert string to integer. And similarly here, it will automatically convert integer to string. That is called auto casting. In Python, auto casting does not happen. In Python, I repeat, auto casting does not happen. Implicit auto casting does not happen in Python. Explicit auto casting, explicit casting is only possible, which means if I really want to convert a value from one data type to another, I have to explicitly write to what kind of data type I wish to convert. So that's why this syntax will have to be written as string. In this case, the integer value I'm converting to string, and when I run this, I'll get the outcome. Okay, so the takeaway from the last part of the syntax is Python does not support implicit auto casting, implicit auto conversion from one data type to another. Python only supports explicit casting. So quickly type these syntaxes to understand some basics on casting. With this, we come to end of data management session. Thank you. See you in the next session where we'll see some basics on date management in Python.